Morning, Pirate family. Welcome back. It is distance learning continued once more, hopefully for the last time this school year. If we're lucky, it's Mr. G. I've lost track of the days. I think it's like something around 71 days of distance learning. I don't know. But I do know this. We clearly need to do a little recapping on yesterday because that video that I posted, man, that didn't work out too well. And a lot of questions coming through, so let's go ahead and start going through our notes. I got a line on my face right now, so I'm going to back out of the frame for a second so we can focus more on this stuff here. Geometry is what we're talking about this time around. This is Unit 9. Hopefully you have this now in your table of contents, and of course the notes in as well. We are, yes, going to go through the notes once more because I don't know if you caught it all while you were writing it all down. What is geometry? Geometry, of course, is the branch of mathematics concerned with properties and relationships of points, lines, angles, curves, surfaces, and solids. So, the shapes, and what makes up the shapes. So all the pieces that a shape comes from, that is what geometry is all about. And that's what we're looking at now in this unit. So, let's get into the core, the skeleton of these shapes, if you will. The lines and the angles and those goodies. So, starting off with the lines. There are tons of types of lines, and they are important to know each one of them. So let's get through them, right? There is the line, there's a line segment, there is the ray, there is perpendicular lines when we're talking about line pairs. You also have parallel lines, and you have just standard intersecting lines. And we're going to get into each one of those here in our notes. Starting off with the line. The line is literally the infinite ongoing piece of line that goes on and on and on and on, kind of like me sometimes in our lectures. There's no beginning and there's no end. I just keep on going, right? I am a line. Who knew? It continues indefinitely in both directions. The way we notate that and we see that is by having arrows drawn on each end of that line. Now, here's the important piece, people, right here. Notation. Notation is very important in geometry, especially when you're identifying lines, angles, rays, and everything else. You have to know how to notate. If you're not notating correctly on your assignment, the one that I gave you yesterday, the one that we're also going to go over here during this video, improper notation is going to lose you half credit. Simple as that. Okay? Now we'll get into that here in a second. But notating a line, you put a small line over the letters. As simple as that. It's geometry. It's basic, right? So here's our line. Arrows on both ends. You give names to the points at the ends of the lines. That's what they do. A, B. This is line A, B. So in order to notate that, if you were asked what is the name of this and how to notate it, you would put the line, smaller version, on top of A, B right next to each other. Okay. Now when it comes to how you put the letters down, I am all about the alphabetical order. That's the way I look at it. So I would try and put the earlier letter, then the later letter, you know what I mean? BA, technically is another way to identify it, but I'm more about the AB. So this is line AB. Okay. Another way of thinking about the line is the horizon. Now granted it does end, but it is of course in the realm of a continuous line when you're looking at it with your vision. Unless you have really good vision, you start seeing the curve of the arch. I'm not getting into that. Okay, moving on to the line segment. Now the line segment does have a beginning and an end point. Segment is our key here. Segment means that we take a piece of the ever-going line and we're just looking at that piece, and that is the line segment. Segments are on the shapes, of course. They're called sides because obviously a square or a cube doesn't keep going when we're looking at the sides of it. So that's where we get line segments, is from looking at sides of shapes. Okay? All kinds of shapes obviously have line segments. The notation, again, just simply putting the line segment over the labeled letters. So once again, this time we're looking at line segment AB. Notice there's no arrow on either end. Usually there's a dot or some kind of ball or something, or even a square to tell you that is the end and beginning point. Sometimes there's nothing, just like that. All you have is the letters to tell you the beginning and the end. But when we notate it, again, we put the smaller version of what it is above the letters. It's not too complex, and it is here in the notes for those that are having problems in the homework. How do you notate? Well, while you were writing these into your notes, you were probably not paying attention very clearly. Right there. Okay. So, line segments. Think about like on a map where they're telling you to go from point A to point B. They don't tell you to keep going. So you're getting that line segment, that section. The blue line here. Obviously not the red because that is a curve. We don't want those. We want straight lines here. Alright. Obviously triangles, another example. Next up, the ray. Now the ray has a beginning, so it starts somewhere, but there's no clear end. So it's an indefinite end. So the way we think about that is think about like the sun, rays of the sun. We know where the sunlight begins, it's at the sun. But they keep going, light keeps traveling through space. That's how we see stars, people. We are looking at their rays of light from other stars. Our sun is a star. I'm not getting into science right now, we're talking math. Anyways, notating a ray, again, guess what? Same thing, put a ray over the labeling of the rays. So we have our ray, a beginning point, A, to an ongoing point, B. Now, when we get into more like rays, you definitely want to make sure you're notating with the beginning point first. So obviously, this needs to be an A-B identification because that is your starting point, that's your ongoing point. So when we're notating, once again, smaller version of the ray above AB. Okay? Rays are also looked at when you're thinking about angles, and we're going to get to those here momentarily. Again, sunlight, your ray. Now, when we get into pairs of lines, they can be in certain conditions, such as a parallel. Parallel lines means that they are never going to cross, ever. Now, we can get into a more indefinite thing and think about like various lines on the coordinate plane. They're going to keep on going and they're never going to cross over. They're parallel. In the real world, we can think about it in the realm of like train tracks. Train tracks are supposed to be parallel, otherwise you get crashed trains, and that's not a good thing. So parallel lines are just two sets of lines, or a set of lines that keep on going and never cross paths. That's parallel. There's not notation in the notes on this. However, when you are notating it, I will show you on the worksheet. Okay? There is a little bit of notating you can do for that to make it a little easier. Shorthand writing, if you think about it. Next up is, of course, intersecting lines. Intersecting lines simply means that they are crossing at some point. It can look like anything in particular, doesn't matter. Any point that they cross over is an intersecting point of intersecting lines. Now, you could have a line here, and then also another line going in this direction. Those are intersecting lines. Again, there's another way to notate those. We'll get more depth into that in the worksheet. Yes, road maps, a lot of intersecting lines there. Not always in order. You got a gridded structure map like Tulsa, and then you got the chaos that's like Oklahoma City. Again, I'm going off. Moving on. Perpendicular lines. In perpendicular lines, you're talking about lines that cross or intersect at points that form right angles. Okay? Perpendicular, think about the coordinate plane again, where the x and the y axis, when they are crossing, they are forming a perpendicular intersection, a perpendicular set of lines. They form 90 degrees on every corner in that intersection when you look at where the two lines meet. Those are perpendicular lines. Again, a nice structured gridded map will show you a lot of perpendicular lines. Intersections are supposed to be like that, or should be like that. Angles. Angles are two rays with the same start point. Okay, there we go. Two rays with the same starting point create your angle. And there are different types of angles. We're going to go through those as well. The starting point of your angle is the vertex. Remember that word, vertex, very important. Vertex means where the angle begins. The starting point where the two rays will go out in whatever direction they're going to create the angle. Okay? And of course the rays are considered the sides. When you are notating rays, it doesn't matter what kind of ray it is, acute, obtuse, straight, zero, whatever, right? When you're notating it, it's really simple. It's the same shape in front of the letter identification. So here we have our angle. This is A, B, C. You can see the bottom, you can see the bottom. A, B, C. B's our vertex. That has to be the way we write this, is in order with a vertex in the middle. Ray to vertex to ray. Okay? So the notation of that is simply putting a small acute angle in front of it. Even if it's obtuse, even if it's a right, even if it's a straight or a zero angle, and those are all the types of angles we're going to talk about. you always put that little acute angle in front to tell you this is angle ABC. Angle ABC. Ordered with the vertex in the middle. Vertex always has to be in the middle. Hopefully they give you letters that make sense. Otherwise it looks weird. Sometimes I've seen angles called CAT where A is the vertex. We'll see what happens. Okay, when you're measuring angles, you utilize, what is this tool called again? Good job, protractor. Very good. Different types of angles. Like I said, there is the zero angle, right angle, acute angle, obtuse angle, and straight angles. We get into supplementary and complementary. We're talking about the pairing of angles. That's a little more important next week. We're not going to worry about that too deeply right here and now. We're worried about these, especially for the assignment you're working on. Okay, what is a zero angle? Zero angle is really where you really have two rays. Technically, think about this. You have two rays that are just sitting on top of each other. Okay, so there's two rays, but when there's zero angle, that means there's literally nothing between them. So they are a zero angle set. Okay. Now, another way to look at a weird one is the straight angle, and that actually comes up on the worksheet. Straight angle is basically a line. Straight angle is a line, but there is a vertex to it. It's just basically saying it's a 180-degree angle, because 180 degrees is a straight line. So that is a straight angle, okay? Right angles. We know those. Those are the 90-degree ones. Those are the ones that give us a nice clean box, if you will, by the vertex. We think of right angles in all types of architecture. Acute angles are less than 90. Any angle that is less than 90 degrees by the protractor's measure tells us it's an acute angle. It's so cute. It's because it's tiny. No, it's an acute angle because it's less than 90 degrees. Even I can't believe I said that. Moving on. Next up, obtuse. Obtuse is where they are greater than 90. Okay? So you have the zero angle, where there's nothing. You have the acute angle, which is less than 90. You have the right angle, which is 90. And then you have the obtuse angle, which is greater than 90. And then you go to the straight angle, which is 180 degrees. So I just literally went through all the types of angles by going by their smallest to largest angle measure. Obtuse, greater than 90. Good? Wonderful. Now, we are going to go ahead and jump from here into the worksheet to look at the assignment that you were given yesterday. Hopefully the board is going to work in our favor. Notating these lines. You were given 3 diagrams. Well, 2 diagrams and a dot matrix. We'll get to that. You are supposed to identify the requested items in there. On the video that I attempted to do yesterday, I gave you the line for number 1. So we go to the diagram here, and any place that you see 2 arrows tells you you're looking at a line. So we have an arrow here, we have an arrow here. So our line is going this way. So we only want to worry about our 2 endpoints that are given, which is the letter B and the letter D. Again, I'm alphabetical based, so please board work with me. B, D would be the name. Don't forget notation. Notation, meaning on top of that BD, there should be that little line on top of it, okay? I'm going to move you down here as well and give you another one. So as I said, there are certain notations that you use for parallel, perpendicular, and intersecting lines. I'm going to give you those notations, but I'm not going to tell you which ones out of here you should put here. That's still your job. If you're looking at parallel lines, what's going to happen is you're going to have your first set of lines that are notated properly. And then when you're talking parallel, they put 2, looks like L's, lowercase L's, that are going longer, a little longer, than the lettering that's there to show you these are parallel to each other. This line is parallel to this line. Again, shortened notation because in math we want to get to the answer as quickly as possible. Perpendicular lines. When they do perpendicular, they're talking in upside down, uppercase T. It presents you those 2 90-degree angles to let you know these are perpendicular. So again, this line is perpendicular to this line. And then finally the intersecting lines. When we're talking the intersecting lines, here's a good one. It's an X. Intersecting. It's intersecting. It doesn't matter what it looks like. It just looks like it's two crossing lines. It looks like a giant X. Again, bigger than the notation of the line, so it doesn't look like one large set of letters. Line here is intersecting to line here. Easy enough? Maybe, maybe not. We'll see. Now, okay, board, be my friend. Hey, yeah, you're working with me today right now. I like that. Oh, nope, there you go. So that middle section is all about angles. Again, you're looking at the diagram here to create the angles it's requesting. Acute, less than 90. Obtuse, greater than 90. Right, 90. Straight, 180 degrees. Remember, when you're notating any of these angles, they all have the same identifying notation in front of them. Every single one of them looks the same. Then what letters they are depends on where you find the angles you need. Slightly questionable, confused? Good. Now you get to figure it out, hopefully. And finally, the last section here is involving, this is what I call a dot matrix. A series of dots in an organized fashion to give you the opportunity to draw within them. Dot matrix. We are creating a diagram like the ones we saw up here, but certain ones in particular. Again, I attempted to do the video yesterday morning, and I gave you guys number 13. And as I said in that video, number 13 gives you not only that answer, but also the answer to 11. Because in number 13, it's asking for line AB, and then ray CE being perpendicular to that. So, as I said, and I'm going to reference the video again, you need to make sure that your line, to start you off, is a very good sized line, because it's going to be utilized, obviously, as you can see in the problems, a couple more times. So there's more things coming off of it. So I've created my line, arrows on both sides. I notate it A, B. So I've created my line, so now I've done 11, and I'm going to do number 13 as well. It's asking for ray CE to be perpendicular. What's perpendicular? 90 degrees. It has to be a 90-degree intersection, and it doesn't have to be necessarily in the center. I can move it over here. And I have labeled it now CE. So I've created my ray, and it is now perpendicular to my line. And I've not only done problem 13, I've done problem 11. So I've provided you with tons of tips and pieces to work through this worksheet. Here's the good news. Based on the level of confusion that occurred yesterday, what I've decided is to pull back today's assignment until next week when we're back in person. And hopefully we can address the issues of confusion and then move forward into the new stuff. So all you need to worry about is make sure those notes are in there in your journal. They make sense to you. And then you've got this worksheet figured out, okay? It is still due by the end of day today. I'm not changing that. Due date is still today. But I am also going to have our Google Meet at 10 o'clock to further help those that need that help. Again, this 10 o'clock Google Meet is for anybody. Anybody in 6th grade Mr. Greenert Math. You can get on. I don't care what hour you are. There's only going to be one meet at 10 o'clock this morning. And we're going to cover this stuff as long as we need to, as many people as coming on asking questions about this stuff. Okay? I may bring up the quiz debacle. Yeah, that's not a good sign, right? Or even the review debacle. Oh my God. We won't get into that right now because I've already run out of time. But 10 o'clock, Google Meet. Anybody that wants it and needs the help, get on and we will discuss more about this and whatever other concerns we need to bring up. Okay? So, take care of it. Hopefully this helped you, as you're probably still struggling for some of you. If not, get back here at 10, and you can ask me questions then. All right? Good. We'll see you then.